In the last section, the last problem we did for the notes, the numbers weren't perfect. There were some fractions, and it was really hard to see that in the graphs. And so we have other methods. We're going to look at two different methods for finding a solution without graphing, because graphing is only so good. It's only as accurate as your graph is, as far as specific values. If it's a nice whole number, easier to find. Fractions, much harder on a graph. So we're going to reduce our systems to just one equation with one variable. If you have two equations, you need two unknowns, two things that you don't know, and you can solve that. If you had three things you didn't know, x, y, and z, like 3 dimensions, then you would need three equations. You need a system of three equations to solve that. If you have one unknown, you only need one equation. And so that's our goal, is to get two equations down to just one. And we're going to use substitution to do this. We've actually done something similar in Chapter 2, but we're going to do it in a new context, and it just looks a little bit different. And so we've got y equals 3x and y equals x minus 2. I'm going to rewrite this a little bit different. I'm going to say that if y equals 3x, then 3x equals y, which is fair. I think you'll agree with me so far, that if y equals 3x, 3x equals y. All right. I also know that y equals x minus 2. Now I can use something called transitivity. In transitivity, we've talked about it in the past. I think I gave the example of if I like Mrs. Gustafson and Mrs. Gustafson likes country music, I must like country music, which is not true. But in math with numbers, it works really well, that if 3x equals y and y equals x minus 2, we can essentially eliminate that middle ground there and say that 3x equals x minus 2. Well, that's nice because that's one equation with one thing we don't know, one unknown. So let's solve for x. I've got 3x equals x minus 2. I got to get all my variables onto one side, and so I'm going to subtract x from both sides. 3x's minus an x gives me 2x's equals negative 2. And if I divide to get x all by itself, I get that x equals negative 1. So I've solved for x. I know what x equals. X equals negative 1. I also know that y equals 3 times x. And so if y equals 3 times x, I know what x is. X is negative 1. So if x is negative 1, y is going to have to equal negative 3. And in fact, if you check it in the other equation as well, if x is negative 1 minus 2, yep, it equals negative 3. So our solution would be negative 1, negative 3. And that works for both equations. And we checked that to make sure that it does in fact work. So that's how we can solve a system of linear equations by substitution, is we're going to substitute 3x for y. Let's do another example. I went through that kind of quickly, but let's do another example. So I've got two more here that I'll do with you. So I know that y equals x plus 1. If they're equal, they're the same. They're exactly the same. There is no difference if they are equal. Absolutely equal. Y is the same as x plus 1. Equal means the same as. So if y is the same as x plus 1, here's a y right there. Y is the same as x plus 1. So instead of x plus 1, instead of y, let's just plus x plus 1. So I've got x plus 1 instead of y. I substituted x plus 1 in for y. And now I've got one equation with one unknown. So I'm going to solve for x. 4x's plus an x, 5x. I solve for x by subtracting from both sides first. I'm going to go over here so I have a little bit more room. So I would end up with 5x equals 5. Well, even just by looking at it, 5 times something equals 5. X has to be 1. But if I divide both sides by 5, I'll get that x equals 1. So I'm halfway there. I know what x is. Now I've got this other equation. Really, I've got two equations that I could use, but the top one is the easiest. I know that y equals x plus 1. Well, I know what x is. X is 1. So that means that y equals 1 plus 1. Y equals 2. So the solution would be 1, 2. And if I check that, 4 times 1 is 4, plus 2 gives me 6. It works. 4 times 1 is 4, plus 2 equals 6. X is 1, y is 2. I found my solution to this system of linear equations. Let's try another one. We've got y equals x plus 3 and y equals 2x plus 5. Again, y is the same as x plus 3. They are exactly the same. So wherever you see a y, you can replace it with x plus 3. There's a y. I can replace y with x plus 3 equals 2x plus 5. Now I've got one equation with one thing I don't know. So I can solve for x. I'm going to get all my variables onto one side. 2x's minus an x gives me 1x. I subtract 5 from both sides to get my variable all by itself. X equals negative 2. So I'm halfway there. I know what x is. Now I got to figure out what y equals. Well, luckily I have an equation that says y equals x plus 3. And I know what x is. X is negative 2. So instead of x, I can put negative 2 plus 3, which means that y is 1. So my solution would be that x is negative 2, y is 1. I have my solution. And if I plug that back in, if y is 1 and x is negative 2, 2 times negative 2 is negative 4 plus 5. Yep, it works. Y equals 1. So I've got it. I've got my solution, negative 2, 1. Give this a try on your own. Pause it. Try solving this system by substitution. I'm assuming you tried it. I'm assuming you did it on your own, paused it, gave it a shot. I'm going to put the solution. Again, make sure that you watch the linked video if you don't get the solution to this correct. So the solution should be 3, negative 2. Again, if you didn't get that answer, if you're not even sure how to start, watch the linked video. Here's another one. Give it a shot, pause it, try it on your own. Assuming you paused it, I'm assuming you tried it on your own. The solution to this one is going to be 3, negative 10. If you didn't get that answer, if you're not even sure where to start, click on the linked video, try it on your own. I'm going to do this one with you, and then there'll be one more that you try on your own. So we've got this equation here, y plus, or the system of linear equations here. We've got a couple options. We could get y by itself or x by itself. Since y does not have a coefficient, there's no number there. I guess there's a 1, but really there's no number there. That would be the easiest one to work with. So to get y by itself, well, okay, I'm going to start over here. I've got y plus 6x equals 11. I'm going to subtract 6x from both sides. So I end up with that y equals negative 6x plus 11. So I've got y by itself. Now I can substitute. I can say y is the same as negative 6x plus 11. There's a y right there. I see it. And so I'm going to substitute. I'm going to say, well, 3x plus 2y. Well, it's not y, though, right? It's y is the same as negative 6x plus 11. Negative 6x plus 11 equals negative 5. So I replaced y with negative 6x plus 11. I substituted that in. Now I'm going to solve for x. I've got one equation, one unknown. I'm going to distribute through the parentheses. 3x minus 12x. Remember, 2 times negative 6 is a negative 12. Plus 22 equals negative 5. I combine my like terms. 3x's minus 12x's is going to give me negative 9x's. Plus 22 equals negative 5. I subtract to isolate the variable. Negative 9x equals negative 27. And that works out pretty nice because when you divide both sides by negative 9, you're going to get that x equals a positive 3. So x is positive 3. We've got x. I'm halfway there. Actually, I'm more than halfway there in this problem. If I know what x is, I can replace it here and say, well, y equals negative 6x plus 11. So that means that y is going to equal negative 6 times 3 plus 11, which is negative 18 plus 11, which gives me y as negative 7. So my solution, 3, negative 7. A lot of work, a lot of algebra, but this is algebra class. And so 3, negative 7 is the solution. And if I look back up here, if x was 3 and y was, oh, no, I forgot, negative 7, 3 times 6, 18, and 18 plus negative 7 does give us 11. And same thing down here. 3 times 3 is 9. 2 times negative 7 is negative 14. 9 plus negative 14, negative 5. So you can substitute back in and see that it does in fact work. Lots of work, lots of algebra. Pause it. Give it a shot on your own. I'm assuming you paused it. I'm assuming you tried it on your own. The solution to this system ends up being negative 1, 6. If you did not get negative 1, 6, or if you're not sure where to start, make sure you pause it and check the linked video and see how to do it. Okay, good luck on the form.